The question is, discuss the nature of bonding in the following coordination entities on the basis of valence bond theory. So the first part is FeCN6, charge on the coordination compound is -4. In the given compound, the oxidation state of Fe is +2. So Cn, the charge on all the Cn is -6, and the total charge on the compound is -4. So the charge on Fe will be +2. The electronic configuration of this compound is Fe is 3d6, because since atomic number of Fe is 26 and its valence electronic configuration is, I will write it down, 4s2 3d6. Okay, 4s2 3d and 6. Okay, so since it is oxidation state is +2, its valence bond configuration or the electronic configuration of Fe will be 3d6. Right. So moving on. Also, Cn is the strong field again, so it will cause the pairing of electrons. So since 6 electrons are present in the d orbital, all of them will get paired, and basically the hybridization will be D2sp3, as there are 6 ligands. So hybridization will be D2sp3, which is an inner orbital complex, right? So therefore the complex is diamagnetic and its geometry is octahedral. Second is FeF6 3 minus. So here you can easily see that the oxidation state of Fe is +3. So its electronic configuration will be D5. And since F is a weak field ligand, it will not lead to the pairing of electrons. So all the 5 electrons will be there as it is, and the hybridization will be sp3d2. The geometry will be octahedral, and it is paramagnetic nature. You can see there are 5 unpaired electrons. Third part is CuC2O4 3. The charge on the coordination compound is -3. So in this given compound, the oxidation state of CO is +3, as you can see. C2O4, one C2O4 holds the charge of -2, so 3 will hold -6, and 3 minus is the entire charge of the coordination compound, so +3 will be the charge of the cobalt metal. Okay, so since it is atomic number is 27, so it will so its ground state configuration is 4s2 3d7, right? So +3 charge, so 3d6 remains configuration in this compound. Isolate is a weak field ligand, so the pairing will not occur. Okay, so the pairing will not occur. Actually, the C2O4 is a strong field ligand. It is written wrong right here. Okay, so oxalate is a strong. Okay, it is strong. Pairing of electron will occur. Okay, right. 6 electrons will get paired, so it will be D2sp3. Here it is. The d orbital is shown here. sp3 D2sp3 will be the hybridization of this compound. Hence, this complex is octahedral in nature and paramagnetic. Okay, this is again wrong. That will be diamagnetic, right? You get confused. Some correction, just like with diamagnetic in nature. So again, COF6 3 minus. So here again the charge on cobalt is +3, but now the pairing will take place. Okay. Sorry, F minus is a weak field ligand, so no pairing of electrons will take place. We know that if the ligand is weak field, we do not pair the electrons. It will just we will just use the above principle and the Pauli exclusion principles. So finally, the hybridization of this coordination compound will become sp3d2. Hence, the geometry of the compound is octahedral and it is paramagnetic in nature. You can see there are 4 electrons unpaired.